Building a large language model from scratch requires feeding it terabytes of raw text data while it runs constantly, day and night. To process all that information, companies have to rent hundreds of specialized graphics cards, keeping them running for weeks or even months. The server bill alone for the process often crosses into the millions of dollars. But you can bypass that entire corporate pipeline. We're going to build a specialized custom AI model from your own laptop in under an hour for less than $5. All you need to start is a simple text file filled with examples of prompts and responses, along with a few dollars to rent space in the cloud. Training your own specialized intelligence is no longer restricted to billion-dollar tech companies. It is a highly accessible, practical skill that anyone can learn to execute. The first step is getting our hands on a starting brain. Normally, AI labs spend their time scraping the web for data, writing the complex mathematical architecture, and paying for that expensive initial training phase. We skip those steps by downloading an open source framework like Llama 3. Companies provide these foundational files for free. We call this a base model. It has massive knowledge but cannot follow instructions. Type the sky is, and it simply predicts the next word, outputting blue. To turn this base model into something useful, we need to place to work on it. We use services like Google Colab Pro or RunPod to rent access to a single high-end server component like an A100 GPU. You pay a few dollars to use the hardware just for the hour you need it. By combining a free pre-trained base model with hourly rented processing power, we completely eliminate the massive upfront costs of AI development. With our hardware rented, we need a workspace to actually write our instructions. This is a Python notebook interface. We're going to load up a pre-made template using tools like Unsloth or Hugging Face TRL. These templates are crucial. They provide the necessary code in neat, readable cells so you don't have to program the complex layers of PyTorch yourself. But if you try to start training right now, you will hit the most common roadblock for beginners. You will run out of memory. A standard large language model is so dense that updating all its internal math at once instantly overloads the GPU and crashes the system. To prevent this, we apply a specific mathematical technique called low-rank adaptation, or LoRA. Instead of forcing the computer to load and update every single parameter in the model, LoRA targets a tiny compressed representation of those weights. It reduces the memory required to run the training by 99%. Before you proceed any further in your notebook, you must locate the LoRa settings cell and activate it. Without LoRa, personal AI training is impossible. With it, consumer-level hardware can handle the exact same logic used by enterprise labs. Now we move into the actual training phase, known as instruction fine-tuning. This is where you upload your custom dataset. You will feed the system a document containing clear examples of a prompt, followed immediately by your ideal response. Once the file is uploaded, you run the main training cell to begin the process. Inside the machine, the model adjusts its mathematical weights and internal connections to mimic the tone of your uploaded text. You monitor this progress on screen. As the system learns, a metric called loss steadily drops, meaning the AI is making fewer errors. By forcing the model to study these specific prompt and response pairs, we transform it from a generic text generator into an obedient, highly specialized assistant. After a few minutes, the progress bar will complete. Your custom training is done. To test the results, type in a highly specific prompt related to the custom niche data you just uploaded. This graphic shows the exact same prompt fed to both models. On the left, the original base model spits out a confused run-on sentence, but on the right, our newly fine-tuned model delivers a perfectly precise response, following your instructions exactly. If you want to push this even further, the major AI companies add one final layer to their development cycle: alignment. Through a process called reinforcement learning from human feedback, actual humans score the model's outputs. This penalizes bad answers and guides the AI toward generating safe, highly accurate responses. But for your own projects, those initial fine-tuning steps are all you need. You now possess a fully customized, localized intelligence engineered for pennies on the dollar.